In this lesson, you will learn to demonstrate the effects of a reflection on a figure. You have already learned that a reflection is a type of transformation where a figure is flipped over an axis so that you can see its mirror image. In this example below, you can see that the line in the center is the axis about which the figure is reflected over. Each vertex is the same distance from the axis as its corresponding vertex is in the reflected image, but from the other direction. A reflection changes the position and flips the orientation from top to bottom or left to right or both, depending on the axis of reflection. It does not, however, change the shape or the size of the figure, so the pre-image and the image are congruent. Recall that the pre-image is the original figure and the image is the transformed figure. Now that you have an idea of what a reflection looks like, let's learn about reflections on a coordinate plane. When a point is reflected across an axis, its coordinates change depending on the axis of reflection. Some popular axes are the y-axis, the x-axis, and the origin. When reflecting a point across the y-axis, it's like using a vertical mirror. The y values remain the same since we are going from side to side, so the image will be on the other side of this y-axis, and the distance from the y-axis will be exactly the same as the distance was with the original point, however, just on the opposite side. So with this original coordinate of 4, 3, its transformed coordinate keeps the same y value, but its x value is the opposite of what it originally was. So 4 becomes negative 4. When reflecting across the x-axis, you're reflecting a point by using a horizontal mirror. So the image will be below the mirror and the point will be as far away from the x-axis as the original one was. So in this situation, the x-coordinates remain the same and the y value transforms into its opposite. So with the example of 4, 3, you can see that 4 stays the same and 3 becomes its opposite, which is negative 3. Finally, when reflecting a point across the origin, it's like using both mirrors. In other words, it's like reflecting by one axis first and then by the other. So both x and y coordinates now become the opposites of what they were. So 4, 3 in this situation becomes negative 4 and negative 3. This means that the transformed coordinates point is the same distance away from the x-axis as the original point was, and the same distance away from the y-axis as its original point was, just on the opposite side. Remember, to reflect a figure, you just need to reflect each vertex's coordinate and then connect them to create the image. Now let's try a problem. Look at this coordinate plane and the figure on it. If the figure is reflected across the y-axis, what are the coordinates of the image? Now in the pre-image, the coordinates are negative 1, 0, 3, 2, and 1, negative 3. To reflect this triangle across the y-axis, we need to reflect each point first and then connect the dots. To reflect across the y-axis, we need to remember that the y values stay the same and the x value becomes its opposite. So, negative 1, 0 becomes the opposite of negative 1, which is positive 1, and then 0 stays the same. For 3, 2, here you could see that the opposite of 3 would be negative 3, whereas the 2's stay the same. Same goes for the final point, where you could see that 1, negative 3 now becomes negative 1, negative 3. So the coordinates of the image will be these 3 coordinates in red. Now let's see what the image looks like. Aha! So you could see that each reflected point is the same distance away from the y-axis as its pre-image. So -1, 0 was 1 unit away from the y-axis. 1, 0 is also 1 unit away. 3, 2 is 3 units away from the y-axis, and right here you could see with -3, 2, it's also 3 units away. You could see that the image of each point, which creates the whole figure, looks like it has been flipped across with the y-axis as the mirror.